system, hopefully, it is not going to be very central in the shop. We have to.
It's a little bit embarrassing, but I show you the principle. It's embarrassing because in principle the system is collapsed already for 6 years. It doesn't work. But because the regulator, Eurotherm regulator, didn't work anymore, but we put now a voltmeter on to regulate again. And that's why usually we knew exactly the pressure immediately. Now we read only volts, but we also always have cars that we know that low amounts of voice corresponds to pressure points in a way. So usually I always write them down. At a certain point I write down the volts and later I recalculate the pressure and then recalculate that to pores.
I mean, the number of pores are higher will be the voltage.
No, the higher the voltage, the higher the pressure, the smaller the pores. Because high pressure, before it opens, is a small pore.
Okay.
That's something to think about. I have to fill it with what first? That takes a while. We always empty the bath downwards here, so I closed it, else it was leaking now.
Right.
And you can forget it. That happened in the past, of course.
يتقفل من تحت. Okay. So really the size of the bath here doesn't matter. We can have a smaller size if we wanted to.
Yes, it's just because we want to. This is the same clamping what I said as the Helium 1-point setup, but then vertical, clamping and moving. Horizontal, yes.
So this is clear.
So the principle is the same. So this kind of things I took with me to another location. Just have a principle to clamp.
Right.
It's a little bit rigid. She measured long tubes recently.
Right.
And I don't want to oil it because then my bath is polluted with oil.
Right.
So that's why it's a little bit difficult. Now we'll take a tube. I have already one. Small one. See if I can make it. A little bit smaller. Here, can you catch it?
Yes.
Try it again. A little bit too much. Oh. This must be it. Now I do the same thing as in the Helium 1-point setup. Taking some parafilm. I want to punch a hole, tiny hole. this side is for the air and nitrogen feed. This one is for this side. Now this part, this is most critical because you want to fill every pore with air without encapsulating air in the holes. So you start at a certain point and then slowly you will saturate the tube, and you can see it because the surface of fluid is floating. So every pore is in this way covered because the air is pressed. Here you see the running the.
I see
so
it.
those are full, and I don't want to trap air underneath.
So you do it slowly.
Because I see when I'm pressurizing it can open more easily and then you have wrong measurements.
Right.
So saturation of the tube, that's in principle the most important
I see.
part. Slowly, and it's there.
Got it.
Now
So
it's
now
full.
it's saturated.
Yeah. Now we want to fix it without leaking. I'm not really used to do it anymore.
But the idea,
Yeah.
yeah.
And then I want to do it as fast as possible to dump it in because
So you
it's
don't
wet and I
wet
don't
it.
want to have it dried again.
Right. Well,
And I want to have a certain surface of at least 10 millimeters above.
oh, so you can see the bubbles enough.
Yeah, but also the compression because I can also put 30 centimeters on top and then it will be more difficult.
Of course, of course. But this doesn't really go into the Laplace equation, does it?
No.
Okay.
Okay. This aside. This one out. That's easy to have a standard feet of water. We don't use water that often, but
This is same the MK water.
yeah,
Usually they use
Yeah.
ethylene.
Ethanol.
ethanol. Yeah.
But today we said let's
Then we
not
have
do
such a jerry can full of ethanol, and that's filling, but also again used. We use it for about a year.
Oh,
Put
okay,
it
so you recycle
here.
it.
Yeah,
Okay.
and we put it over such a paper, so tiny filter just to take the particles out, and then we will use it again.
Got it. I understand now. That makes more sense.
Now the only thing is I have to find 0.0 because there is that part in the voltmeter. And I'm going to have my right hand. I'll run too fast maybe. I have even smaller ones. This is pretty rough. 0.1. I'm now at 1.96. That's this pressure, and that corresponds about with huge pores.
Of course, this is for ethanol, but for us, it's going to be-
You're right. Yeah, completely right. Sorry. I'm not thinking in water.
Yeah.
Yeah, you're right.
So
Yeah.
for us, this is going to be even
Higher.
larger.
Yeah.
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 Even larger holes.
Yeah. Now I have to be careful because it can be suddenly when it's very open. I want
I
to.
see. And it's nice that you have no leaks at the parafilm.
No. Just start building up. So
Yeah.
I will take up a flashlight because I hope that we see just 10 and then 20.
I
and
see.
then 30.
Nice.
What are you controlling from here? Voltage?
Yeah, don't worry about that. For them, their system broke down, so they cannot measure pressure anymore. But for us, if we're going to build one, we're just going to have a pressure gauge. So for them, they measure the pressure through measuring the voltage, but we don't have to do that ourselves. For us, we can have a better
So
system.
that's why it's a little bit embarrassing because I prefer to set the pressure
Right,
there.
right.
You can see the pressure immediately.
Right.
If we have budget, we will.
Change it.
Yeah.
So he's increasing the voltage, that increases the pressure, and we'll see when we start seeing bubbles.
When I know that it's coming up at 2 bars or whatever, then I can aim for it. But now I really
Yeah.
have no clue.
Yeah. But this is just a tube that has emulsions but doesn't have.
No, it must be bad tube. Just I picked it out of a box.
It
So
doesn't
as
have
delivered.
emulsion.
So I don't think there's a layer on top.
Oh no!
This is
no.
just raw tube.
Got it. Okay.
The only thing is that it can be a core stack tube. I don't expect it because it was not a box from core stack.
Okay.
Because that's all there and it was just
No
extra material. So I suppose it's another.
The other company is called Inicron, I think.
Innopore.
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 Yeah. And CTI is also making supports. CTI is French,
Mm-hmm.
a French company. Usually I compress it with my finger for a moment. No.
Gas
I
is
didn't
controlled by
check
the
if the-
potential.
Yes.
If the gas came out, I expected that it was running because Miranda used it in recently.
The flow of gas is controlled by the
The
potential.
pressure. Right. It's the pressure that is regulated.
Yeah.
Output pressure.
Pressure. Pressure between the inside of the tube and air pressure, the gauge pressure, atmospheric pressure. So you have air going through here. What's pushing it? A controller. How do you choose that controller? Through the voltage. But basically, you have a pressure controller. It's controlling how much more pressure there is inside the tube than outside the tube.
Pressure difference.
Pressure difference. Pressure outside is 1 bar, more or less. Yeah, actually, that is an issue. That if you really put it in a deep tank, you also have the fluid pressure.
Yeah, and even with the tiny pore, of the big pores, the air pressure of the outside world.
Yes, it's hindering.
Because the variation of 30 millibars or whatever can have already some influence.
Mhm.
better check if I have gas pressure on these.
See bubbles?
Oh, suddenly it came. Yeah. So we couldn't do this. This is a homogeneous.
Distribution.
Yeah. Suddenly.
But you was going to do it?
Huh? No. Yeah, now I can't do anything more. I hope that we could see 10 and then 20
But
and
these
then
are complex.
100 and this is thousands for more.
Yeah. So what we conclude from this?
Oh, then I write down this corresponding with the pressure I have now, and with the
How much
Laplace
pressure you
equation I can calculate this pore, and this is the homogeneous pore, because you have that pore size distribution usually in material,
Yes.
and this is the start of the flank. If it's going like this, we are now here, just starting the. If I give a little bit more pressure, then you see more bubbles, so then also a little bit tinier pores come in.
I see.
So I've tried to do it as narrow as possible,
You're reducing the potential now?
a little bit more.
Exerting more potential.
Yeah, doesn't change that much.
If you increase the pressure, more bubbles should come out.
Yeah, because the largest one will stay open, and the smallest one will go open.
Open.
So you have more.
Because of the pressure inside the tube is
Yeah.
going to increase.
This is higher. No, we don't see that. I will go down.
This raw tube is very porous.
This one's porous. Yeah. But now, because it's open, we soaked it in the beginning to cover it completely with water. But now you have all air inside.
Air and nitrogen.
Nitrogen, sorry.
Okay.
Yeah, at least gas. I have to
Yes.
mention gas. Maybe I can get it out. Maybe. Not sure. No, it's still bubbling. So they're open and they're difficult to get wet water again inside.
Inside. Because the gas is still in
Yeah,
the,
yeah. Then we have to build it out, soak it again, mount it, and then start all over. Because then you have a completely filled support.
Let me explain that. Nitrogen is coming from here.
Yeah. From
Okay.
here.
Yes. And it is. Where is the outlet?
This is blocked.
Okay. This
There's
is
no
complete
outlet, so the pressure is
building inside.
continuously. Yeah.
Okay.
So if you carefully build it up in pressure,
Mhm.
and every point you have to wait for a minute to give it time. So we will do it all over. So let's-
So you are regulating potential from there.
Yeah. And with potential, I feed the regulator because it's broken down, and this is the only possibility to regulate it now. Usually, I should put in 0.01 bar. Go.
But here,
0.02
here
bar.
I don't see the potential connection here.
Now let's see. This is the regulator.
Okay. Gas regulator.
There is the pressure
Okay.
regulated and built up, and that's just communicating vessel into the.
Understood.
So in this is the pressure regulator.
And the upper part is potential state.
Yeah, just to make it working. Yeah, now we have here one because it's more open.
Here we have two.
Yeah. So that's why if you change, you always have to wait for a minute to give to make the circumstances equal, to give it time to open pores. But this is pretty frustrating work if you're looking for the few defects in the under material. Because I always say I want to know the amount of defects, exact. Yeah, and then they have to measure. And if you're not measuring good, then they say, oh, it's 0, there are no defects. And I can't rely on that then. So they have to be accurate. They have to be sure that they have a good measurement.
This is actually not your job. Somebody else do it.
Yeah, someone else. I do it sometimes with new material, then I want to know it. But when it's not new anymore, then I won't do it. Here we have a few more now.
But it is at the maybe leakage at the corners. See, from this side.
Yeah. Yeah.
Because of
We
parafilm sealing.
always exclude the first 2 centimeters because it can be information from
from the bottom.
yeah, from the ceilings, from the bottoms, from the
maybe you
cutting.
put the-
Yeah. So we always count this.
yeah, because if but in you see the nearby area there is no.
Yeah.
But
this-
what about these spherical kind of? These are particles, alumina particles or
Air.
bubbles?
All air. There's no particle at all. So they almost start, or they are still at the surface of the old measurement now, because we have wrong information. But because here is one in the middle coming up.
Yes.
And here a hair, so you have a bubble and a hairline. Here, pop, open, pop, open. You see them coming?
Yes.
That's why you have to
Vertical,
give
yeah.
it time, 1 minute of time. And then after a minute you start counting. So you
They
say
are in line,
Yeah.
right?
Yeah.
In the same line here.
Oh, hey.
Of is dit ook voor je?
Nee, het is een support, want ik wil ze even de variatie laten zien. En ze zei, ah, het hoeft niet in ethanol hoor. Dus ik heb hem met water gevuld.
Ja.
But when the potential is above 3 volt, then the bubbles appear.
Yeah, that's your point then. Yeah. And then you count the bubbles. In this case it's, nou ja,
Countless.
almost. If you're going to count it, you will reach 150, I think. Something like that. It can also be an estimate. It's possible to count them up to 50, 60, but then it will be
I
difficult.
think 4-5% should be here to count.
Yeah, but if it's 170 or 210, the line, you have the line already, your result. So, I have a feeling of the bubble point. Yes? I will let it brush for a moment. Hoppa.
And the potential is 3.6, it's almost.
Yeah. Yeah, this is extreme.
Looks nice now.
Brushing in your aquarium,
Yeah.
taking air into your aquarium.
Maybe that's a new product from
Ja, bruisblokjes.